everyone. Good morning. Dear authors and invited guests, welcome to Technical Session 4B. Myself, Ishita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information Communication Technology for Competitive Strategies, ICTCS 2024, Jaipur, India. The 9th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 20th and the 21st of December 2024. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for the question and answer. On 7 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us to the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session. We have with us Professor Jyoti Shekhawat. Professor Jyoti Shekhawat is currently serving as an assistant professor at Vivekananda Global University, Jaipur. She holds an MTech in computer science and engineering and is currently pursuing a PhD from Banasthi University. With over 7 years of teaching experience, she has published 11 research papers in Scopus Index journals. We welcome you, ma'am. Ma'am, you're on mute.
Thank you, ma'am.
Okay, so we'll be beginning with the paper presenters. I'd like to invite our first paper presenter for the session, Jyotsana, with the paper titled A Comparative Study of Deep Learning Approaches for Intrusion Detection Systems Across Various Attack Types. Ma'am, if you're ready, you may start your presentation.
Yes, ma'am. Wait a minute. I just share my screen.
Sure, ma'am.
Good morning to all. It is visible.
Yes, ma'am, it is visible. Please go ahead.
Good morning to everyone. Myself, Jyotsna Vilas Barpute. I am from Mansarovar Global University, Bhopal, Department of Computer Engineering. Today, I am going to present a deep learning approaches for the intrusion detection system for the various types of the attack under the guidance of Dr. Sanjay Bhargava. So, my table contains our introduction, traditional ideas versus deep learning ideas, problem statement, objective, literature survey, challenges and gaps. Then key attack types, I'm going to focus. Then deep learning approaches for the ideas, comparison across the attacks types, conclusion and references. So introduction, and intrusion detection system is a security tool that monitor the network traffic for the suspicious activity, identifying the unauthorized access, potential threats, and usual behavior. So it sends alerts the administration when it detects the anomalies, helping them respond to the cyber threats. But the increasing sophistication of the cyber attacks, deep learning offers a powerful techniques to enhance the ideas by recognizing the complex attacks patterns and detecting the anomalies. So traditional versus deep learning ideas. The traditional ideas rely on the either signature based or the anomaly based. Signature based ideas that like just matching the patterns with the anomaly based ideas. And the anomaly detection is like new patterns attacks often produce a false positive, and especially for the unknown and modified threats. But the deep learning based ideas allows it to detect the both unknown as well as known attack with a high accuracy. This adaptability makes it more effective for the evolving the threats, although they require more computational resources and the large data set for the training. So the problem statement, current deep learning based idea solutions struggle with the consistent detection across the different types of the attack due to the imbalanced data set and varying the attacks pattern. High computational requirement limits the real-time applicability and the lack of explainability, high trust and the adoption in the critical network environment. This limitation prevents the effective ideas deployment in the diverse dynamic network environments, underscoring the needs for the ideas that is accurate, computationally efficient, and explainable, supporting robust defense against the evolving cyber threats. So objective, to develop the robust and efficient deep learning based ideas that overcome the challenges related inconsistent performance across attack types, database imbalance, high computational and limited explainability. The goal is enhance the ideas detection accuracy, adaptability, and the various attacks scenarios and interpretably making it vital for the real world network security applications. So I have used number of papers for studying this approach, and some of them on my screen. So like intrusion detection for the 1999 DEPRA offline. So it actually focuses on the real world accuracy of the different kinds of the attacks, and it allows the consistent comparison inspired new the detection methods algorithm. But the disadvantage, it struggled the real network conditions, so that it cannot be give that much accuracy. So accuracy of this paper is near about the 90%. Then second is the deep learning approaches for the ideas like the network intrusion detection. So it generally focus on the NIDS only, and detecting the like intrusion detection for the network for the detecting cyber attacks. And the advantage of this, it is the making the effective for the identify the various cyber threats in the complex network. But the disadvantage is like it is the real-time deployment and increase the risk of the overfitting. So it near about the accuracy is 90%. Then deep learning approaches for the intrusion detection for the neural network. So it actually focuses on the network traffic to improve the accuracy of the detecting the cyber attacks. And the advantage, we can say, like the various type of the network traffic and evolving the attacks, different patterns it can be recognized. But the disadvantage is that which can be large data set, it can be hamper, and it is the 90 give near about the 90% accuracy. Then intrusion detection system using hybrid neural network. So it paper focuses on the performance and adaptability of the various types of the attack. And the advantage, it flexibility for the various network environments and enhance the robustness, reducing the false positive rate. And the disadvantage, we can say, the longer training time required for the complicated practical deployment, and it gives the 95% accuracy. Then next paper is the anomaly detection autoencoders. So it paper focuses on the highly dimensional data, and we can say like advantage, it gives the high flexibility across the various data types, and the interoperability, compiling time, and understanding reasons is quite difficult for this. Then next paper is the surviving intrusion detection techniques for the deep learning. It detects the capability of the effective IDS and system, like insights how deep learning can enhance the accuracy and identify the key trends for this. And the disadvantage, rapid evolution, that the field cloud could render some methods quickly and outdated. Next paper is the deep learning for the MIT Press. Like it focuses on the practical application across the various domains, and the disadvantage of this, accessible for the both beginners and the expert. And the disadvantage is outdated due to the rapid advancement in the field of the deep learning. Then next paper is the deep learning nature. So it is generally focuses on the highlights its transformative impact on the machine learning. But it advantage is authoritative insight for the leading expert. But the disadvantage is like it can outdated quickly, so we can't use as it is for the next any kind of the recognized attack. Then next paper is intrusion detection. So here what again the various data type, it is dependent on the data quality. It is the disadvantage of the deep learning approaches for the new intrusion detection system. It focuses on the network security, but and gives the advantage like identifying the challenges with the suggesting future improvements. But the disadvantage is like rapid evolution of the deep learning. Then next paper is a long short-term memory neural computation. So it paper focuses on the long-term dependencies in a sequential data, and it's showing the improved performance over the traditional RNN. But the disadvantage is the decision making process quite difficult over here. Then next is the improved CNN based like neural intrusion detection system, and it's focusing on the detection of the accuracy, efficiency, again the variety of the cyber threat. But the advantage of this is the detection accuracy is efficient for the real process with the adaptability of the various network, and the disadvantage, the quality of the training data is quite difficult. Next paper is the anomaly detection for the journal of the network and the computer network. So complex attack types generally it focuses, and it gives the robustness in the demonstrating of the robustness in a real world application. But the disadvantage is the computational resources and have the interoperability issues. Then next paper is a new approaches for the intrusion detection using the CNN. It improves the feature of the extraction and the classification, and advantage is the scalability for the large data set. But the disadvantage, the interoperability is limited for this. So this is the disadvantage. Then next paper is the detecting
Excuse me, ma'am.
probe attack. It generally focuses
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
yeah. Yeah. So these are the different kinds of the papers I have. So each and every paper, just like there is a something which happening for the finding out the different kinds of the attack, but it giving the different kinds of some real time disadvantage. So I have a number of papers over here. So near about I have used 44 papers for this. So all of this is in the summarization, just I need to be due to the time limitation, I just let you know, like number of papers for the ideas is quietly have overfitting problem or data imbalance or the real time application. There is the something that is a disadvantage for this. But so on by different kinds of number of papers I have read, and I find out the some research gap, like the generalization to the unseen attack, then real world applicabilities, scalability in a real time performance, for false positive reduction. These are the gaps I have by using this all the literature review. And the challenges also, data imbalance, then resource, actually I already told, like the explainability, scalability, these are the challenges for these different kinds of the reading outcomes. Then the also I have a number of types of attacks like DOS and probe, U2R and R2L. That this kind of attack I'm going to find out the by using all this paper, reading all this paper, and how the machine learning is important to find out the with the high accuracy by using the IDS. So I have a number of these different kinds of key attack happen regularly or happen more time. So these are the different kinds of attack. Then deep learning approaches I have used, like I have going to use in my proposed system is a CNN and RNN, LSTM and hybrid model. So just the information, like CNN is for ideas how it is important, and CNN is widely used for the ideas. Then next is the RNN. Then RNN is the sequence is handled to build the sequential data, which is quite difficult for the ideas and give the high accuracy. So RNN used for that. Then long term and short term model is useful for the like different types of the development overcome with the vanishing gradient issues. So that's why LSTM is used. Then autoencoders for the ideas, like it is an unsupervised learning model and anomaly detection in the ideas, so it is important for that. And hybrid model like the CNN and LSTM is a combination and gives the better approach for the overall performance. For that I have find out the different kinds of the data set, like the KDD 99, NSL KDD, IDS 2018, different kinds of the attack. And I have used a number of deep learning classifiers over there. So I got the attack like a frequency of the attack catching is like For CNN, it gives the high accuracy. For probe is also high, but U2R is medium and R12 is low. So CNN is not that much compatible for the U2R and R12. Then RNN again medium, medium and high, high. So it is quite good in for the U2R and R12, but DOS and probe attack, it cannot be give that much accuracy. Then LSTM is the again same, like it's not giving the high accuracy for every condition. It's quite medium and high. Then auto encoders, it's high, medium,
I'm
low.
really sorry to disturb you again, but
Yeah, yes, ma'am. It's
could you
just
please shift to the conclusions because the time
yes,
limit
ma'am.
is actually,
Yes,
yeah,
ma'am. Yes, ma'am.
yeah.
So the conclusion of my paper is that the deep learning offers a promising solutions for the enhancing the effectiveness of the incident detection system. Different models provides the varying the levels of the performance across the different types of the attacks, but with the increasing complexity and the resources demand. So the future study should aim at the creating the models that are the both more efficient and easier to interpret, as well as the addressing the data challenges through the techniques like the data augmentation or the synthetic data generation. This advancement would help bring the deep learning based ideas closer to the real world deployment, improving the security of the modern networks. Yeah. Yeah. Thank you.
Ma'am Jyoti, would you like to ask any questions?
I just want to ask that what are the next step in your research? You just explain it.
So yeah, actually the whatever I have read till date, it's generally not for the real time data set. So I'm going to use, or I'm trying to use for the real time data set, and uh, overall the result on the real time data set. So I'm trying to use build ideas for the real time data set and find the attacks for over that.
And how did you validate the accuracy or reliability of your result?
Actually, it depend upon the different kinds of algorithms used for that.
Okay, ma'am. It's okay. Thank you.
Thank you so much, ma'am.
Thank you, ma'am. We will be proceeding with the next paper presenter. I'd like to invite paper presenter Nuthana Kanti with the paper titled A Comprehensive Learning for Effective Unit for Perspective Lung Cancer Identification. So if you're ready, then you may start with your presentation.
Yeah. Good morning, all. Hello, is this my voice is audible?
Yes, sir, you're audible.
Yeah. Is this my screen is visible?
Yes, sir, it is visible. Please go
Yeah.
ahead.
Yeah. Once again, good morning, everyone. This is Dr. Nutanakandi Bhaskar, Associate Professor from CMR Technical Campus, Hyderabad. My paper ID is 160. The title of my paper is A Comprehensive Learning for Effective Unit for Perceptive Lung Cancer Identification. So now I'm going to discuss about my paper. The content is abstract, introduction, problem definition, objectives, methodology, results and discussion, conclusion, references. Coming to the abstract, here the lung cancer is very dangerous in nowadays. So it is affecting everyone. So we are going to identify the lung cancer as soon as possible, so that maybe we can provide a good solution for the radiologist if they are not going to identify a small nodule, so that we can identify the uh, cancer, which is very small nodule also in the lung. For that, in this work, we have considered a lung Luna 16 dataset and we applied unit architecture. For this, we are analyzed a small nodules also. For that purpose, we did this work. So we have taken only online data set as a starting the process. So coming to the introduction, as I mentioned just now, the majority of techniques maybe the radiologists are going to use. For that, the judgment sometimes maybe it is miss or human error because the nodules are very small. So the early stage, it is not possible to identify the radiologist. So our motto is to identify the lung nodules in the early stage, maybe the smaller size. So that we can say we can suggest some treatment to the doctors so that maybe they will start their treatment early so that we can save some lives. So this is our things. That is why nowadays the deep learning techniques are very famous to uh, very famous to classify and train the things, so that we used unit models to, in this work we used unit models, and we identified classified a nodule as a lung cancer nodule or not. Coming to the problem definition, the skilled radiologist may have difficulty identifying the growth because they might be a small size. So for this, we're using enormous data set of annotated imaging to train deep learning algorithms. It is possible to teach the fine characteristics, that is distinguish malignant nodule against healthy tissues. So that is what, when the data set may be error, maybe things are maybe moves too bad. That is why. So these are the problems we identified based on the literature survey. For that, our objectives of this work is individualized healthcare and drug discovery are two other areas where deep learning shows possibilities. These models, whatever the model we applied, that is going to assist researchers in finding possible novel drug targets and also forecasting a patient possible response to various therapies by analyzing numerous volumes of medical data. Maybe this result in this criteria for more individualization and efficient treatments. For this, we used the unit model. This is methodology we applied in this work. Unit model we have taken. The approach of this implementation of my procedure is we have taken the processed workflow of data collection from Luna 16. For that, we have pre-processed the data. After pre-processing, we have converted the data into array format because to train more data, because Luna 16 is having 120 GB of data. So that we have taken the data. That is why we are converted into array. And the adjustment the channels, formats, and normalizing were applied for pre-processing. Later, we applied the model and the efficient NetB to all these model. We have taken some consideration of the features. So finally, we are going to evaluate, and finally we are classified the given images are having nodules or not. Those nodules are even, that is maybe the lung nodules or not. So these are the results we got from the this model. These are the target mass we have taken. These are the predicted mass we are identified. Finally, the results are, we have taken the results in the terms of accuracy and IOU score and the loss analysis of the model. They are coming to the conclusion. Finally, we got a the benefit, the good comparatively existing work. Maybe this work may be helpful for the radiologist because it is provided a good result comparatively the existing results. Maybe the maybe substantial result, not good, maybe substantial result, because we have taken Luna 16 data set. So in future, we are trying to get the original real-time data. My college is having medical college also. Recently, they are started, so that we are trying to get the data. The data is somewhat direct data. That is why we are doing pre-processing now. Once it will run, same model we are trying to apply the real-time data. Maybe I am expecting the results may be more or less good than whatever the work now I am presenting. These are the references we have considered in this work. Thank you.
Thank you, sir. Ma'am, would you like to ask any question?
Yeah, ma'am. Sir, I just want to ask you that you have choose. There are lots of deep learning approaches. Okay, then why you choose this approach? Are you
Yeah, madam. Actually, this is the basic work we are started. So that we have taken unit model because it is somewhat good for the medical images. Whatever the earlier research has done, we have studied some literature survey. Most of the medical related research is used for this unit. That is why we have chosen initially unit. So we'll try other models also. So this is the starting work we have converted into the paper, madam.
okay? And what about data, sir?
Luna 16 dataset, madam, it is available online, madam.
Okay, ठीक है, ma'am. Thank you.
Yeah.
Presenter Vishal with the paper titled Deep Learning Based Hierarchical Attention Mechanism for Risk Production. So if you're ready, you may start with the presentation.
Yes, good morning, ma'am. I just share my screen.
Sure, sir.
Is my screen visible, ma'am?
Yes, sir, it is visible.
Okay, I just start. Okay, so good morning, one and all. So today's my paper title is Deep Learning Based Hierarchical Attention Mechanism for the Risk Prediction, paper ID 210. So myself, Vishal S. Burguzar, I'm from Computer Engineering, Datta Megi College of Engineering, Airoli, and working in Information Technology Department, AP Shah Institute of Technology, Thane. So I'm going to start it with my abstract introduction, literature review, proposed system, my implementation flow, and the result. And after that, the conclusion and future scope about my research work. Starting with my abstract. So if you see the current scenario in which whatever we are going to find out in terms of the attacks, right? So the true positive and the false positive of that particular attack is very much important. Along with that true positive and false positive, we need to save the time for the security persons who is going to handle those kind of the attacks in real time scenario, right? So in order to find the whether the risk of that particular attack, that is very much crucial in this particular point of time. So whatever the old one dimensional analytical methods are there, right, that are very old one, and there will be a new deep learning method that needs to be come into the picture as in terms of hierarchical attention mechanism, where this mechanism we have used in order to two tiered weighting system which apply on the different network parameters to providing a clear picture on the security risk and their kinds of observation. And with by using this hierarchical attention method assessment, we are going to provide in terms of the great accuracy of 97.3%, and of the F1 score is 98% near about. So in terms of the introduction, as I have just mentioned, the security risk assessment is very much important nowadays, because we know that the emergence of sophisticated cyber threats now coming up, the variety or the flavors of the cyber attacks that are coming up in a large scale. And for that, this particular approach needs to be have with having a greater detection and the greater along with the accuracy and along with its risk. If we are going to come up then to countermeasure to these particular cyber threats, that will be a very much fine. So these are the some papers that I have we have reviewed. The first one is in the IEEE transaction paper of information forensic security in 2022, where they have used LSTM and autoencoder architecture in their methodology, right? So by using that, because whatever the data sets they have used in their the sequential data sets, right? And for that, they have used the LSTM and autoencoders in order to temporary sequence and to learn the unlabeled input data approach they have used. So by using, I have just mentioned here the two review papers, because both of the review papers I have reviewed and I have used in our methodology. So that is why we have restricted up to the only two papers over here. The second one, the IEEE transaction against 2018 paper, which having an attention mechanism, which will be able to determine the weighting system of in their attention networks, and which will be attention. I'm sorry, I just disconnected. I just share my screen again. Yes, my screen is visible. I'm audible. Can you confirm?
Yes, sir, you're audible.
Okay.
Continue, please.
So both of the approaches we have used in our work. So this is my proposed system where whatever the input data sets that we have used, right? So actually we are doing the ranking characteristics according to how important they are in the relocation to possible the security of the risk, right? So whatever the raw attack data is going to be there, right? The feature extraction we have done in the different layers, right? So for example, the in terms of the low level, mid level, and the high level, right? So for example, the time oriented can be the features, protocol based can be one of the features, or you can say that behavior pattern is also one of the features. So these are
Hello.
categorized into the upper, middle, and the lower level of the features, right? And after that, the same low, middle, and high level of features extracted, that we are going to find out the attention mechanism for all these kind of the layers, right? For example, if we are considering the low attention, then you can consider the packet sizes, or you can also consider here the IP addresses, right? If you are consider the mid level of the attention, then you can also consider the persistent login failure you can consider. If you are going to consider for the high attention mechanism, then we can have various type of the attacks. For example, DDoS attack is there, brute force attack is there, and all, right? So this attention mechanism, which will be help to determine the level of importance of each of the components and each of the layer level by giving the attention score, right? And these are the attention scores, and these are the attention scores we are going to aggregate over here. In terms of, we are going to merge all these attention features into a single vector that indicate over the risk, and then our model can rank these particular characteristics, or you can say that for all these components, it will be in dynamic in nature, right? So that the dynamically we are able to find out the risk of any kind of the attacks that are going to be happen in a real time. Okay, so this is the overall proposed architecture that we have implemented, right? So for implementation layer, we have used here the NSL KDD, the benchmark data sets, right? So obviously in if you consider some kind of the limitations are also is there. For example, age of the data set can be a certain inherent biases over here, right? But if we needs to have some kind of the primarily comprehensive positive attributes, then we have used this NSL KDD data. Then in the data pre-processing part, if you see here, equation first, which we have an attention process at the each of the feature levels that we have just discussed in the proposed system, right? Where here the E of ij, the attention score of jth feature in the ith data instances, where the xi is nothing but the feature vector over the This WF is nothing but my wet matrices, and the BFF is nothing but the biases, and here the RELU is nothing but activation function, that is non-linearity into the model rectified linear unit we have used, which is the base fit for the hidden layer, right? So that is why this pre-processing we have used. Then the input parameters for our implementation, we have used the number of layers to the 3 dimension of hidden layers. So why dimension of hidden layers is been increasing the order, because we are using the hierarchical model, and the top.
There's an issue with your internet connection.
Yeah, I just shared my screen. Sorry for
Sure, sure.
interruption. Okay. Yes, and then so that is the reason why I have using the hidden layer side increasing order. Then the learning rate. So I've used 0.001 for the hyperparameter, to which will be find out the weight of the network that will be changed from to in order to use for the gradient of the loss function, and the dropout rate of 0.5 for for avoiding the overfitting that I have used, and the rectified linear unit for which will be best fit for the hidden layer. So that is why we have used in our implementation. And these are the some performance metrics we have used: accuracy, precision, Drupal, and F1 score, in order to compare with the existing model, and how our model is better as compared to the result part we have discussed. And here is the HIM output, the hierarchical attention mechanism, that proposed system which I have just shown you. So which will be results into the, these are the some features which will along with its attention score. So significance of these axis of abnormal port, if you consider, here's the 0.85, which will be having an highest significance of this particular feature. So we are going to uh, provide the score to these particular features with respect to the our model gives an output. As if you see, for the duration of connection, is it will be having the very less score of the attention, that the significance of that, it will be only 0.55 as compared to the axis of abnormal port. So with respect to this attention score, we are able to find out the risk prediction of that particular different features, and obviously along with the any kind of the
Excuse me,
network
sir.
attack will happen. Yeah.
I'm
And
really sorry
finally,
to disturb, but could you please
yes, ma'am.
move to the conclusions because the time limit.
Yeah, ma'am. So in the resultant discussion, obviously, as I have demonstrated, so 97.3% accuracy and F1 score is 0.98% is as compared to the existing model. And thus, these comprehensive models seamlessly use HM for the risk prediction, and the accuracy and detection is also improved as compared to the previous one. And the future scope, which can be extended our works in augmenting the security and efficiency of digital networks across all the geographical boundaries, we can also use, or including the integration of this proposed model with other security measures also can be done as a part of the future work. And these are the my references which we have gone through. Thank you.
Hello.
Thank you, sir. Ma'am, do you have any questions?
Yeah, sir, you just tell me one question, that are you able to highlight the most innovative aspect of your research?
Hello.
Hello?
Yes, ma'am. I have highlighted the importance of the rank characteristics among whatever the features which we have calculated for that particular attack pattern, so that the by using that importance of feature level, we are going to detect the attacks, whether it will be false positive or the false negative, and based upon that, the risk prediction and the score is also going to be evaluated, and this is going to be done in the dynamically. So it will be very much essential in a current scenario as we are going to concern.
Okay, thank you.
Thank you, ma'am.
Thank you, ma'am. Thank you, sir. We'll be proceeding with our previous presenter who is now with us. Paper presenter Bahu Sahib with the paper titled Deep in Machine Learning Techniques for Detecting
Yes.
Unbalanced Traffic. So if you're
Am I
ready, then you
audible?
please start your presentation.
M- My voice is clear. Am I audible? Hello.
Yes, his voice is audible. Yes,
Okay,
sir.
thank you. Uh, Good morning, all of you. My paper presentation of deep learning and machine learning techniques for the detecting unbalanced network traffic. My paper ID is 219. Under the guidance of Purushottam R. Patil, sir. Okay, I am a PhD scholar student of Sandeep University, Nashik. Okay. So these are the content of my 2 presentation: abstract, introduction, literature survey, methodology, evolution matrix, benchmark data sets, and the conclusion, and last is the references. Okay. Let's move to the abstract of my paper. Okay, so normally NIDS is nothing but the network intrusion detection system. It is now safeguard digital infrastructure from the cyber threat. Now, some of the challenges detecting the intrusion within the unbalanced network traffic, where legitimate traffic significantly override the malicious traffic. So, to improving the performance of NIDs, so we have faced the number of challenges nowadays. So this review or my paper is a review paper explore the machine and deep learning techniques to design to address and complexities of unbalanced network traffic in intrusion detection. Normally, this review highlights how these techniques improve the detection accuracy, data augmentation, as well as in the hybrid mode. Also, while minimizing the false positive and negative by analyzing the recent advancements in machine learning, deep learning, as well as cost-sensitive learning optimizing strategy. Okay. Now, our finding in this paper is that we suggest an integrating multiple machine learning and deep learning algorithm can provide the scalable and effective solution for modern NIDs. Okay. Also enabling enhanced detection capability in highly imbalanced network environment. So this review identified the limitation in traditional oversampling and undersampling methods, emphasize the need of robust approaches to generalize the real world conditions. So our findings suggest the integrating multiple ML and DL algorithms as a scalable solution for modern NIDs and guiding the future research work toward the more adaptive and effective anomaly detection framework to enhance the network security. Next, introduction. So normally my paper contribute the following things. First is the deep learning, cost sensitive learning, and assembling the model take the intelligent approach to detecting the imbalanced network traffic in network integration detection system. So normally all these systems compressed and presented over sampling the method with the traditional techniques and the supervisor model pointing out the problem of the later and need for the efficient and easily scalable solutions. So also a new multi-algorithm approach to increase the identification accuracy and minimize the number of false positive in unbalanced network setting. The current system suggests that the novel adaptive framework that analyzes the traffic characteristics and select the best algorithm combination using AHP among the other optimization process. So this is the AI base for unbalanced network traffic intrusion detection systems. So normally, if you take the example of machine learning or deep learning, okay, so these are the systems or AI for the unbalanced network traffic intrusion detection system can be managed and handled by the important handle the network traffic this technology. uh, Most of the when you use the NIS, when develop the NIS by using the machine learning or deep learning, the some methods involves the three important phases that they follow. They include the data pre-processing, training, and testing. So these are the three important phases for the AI ML based the traffic analysis. Now in data pre-processing category, what happened? The three important things is that the algorithm take the raw data inputs and encoding and normalizing using the data pre-processing techniques among other system techniques. It may also include the data cleaning where one remove the record containing missing on multiple value to increase the data quality. After the pre-processing, the data split into two subset, that is training and testings. Okay, so the combination of training set and testing set which prepare the divide by in the ratio of 80-20, where more significant part is the training and remaining for the testings. Okay, so these are the train ML DL training phase, training data set, and for the testing phase, the testing data set. and we have to make the prediction even in an attacks. Okay, so these are the introduction detection system methodology using ML and DL system. So as a literature concern point of view, we divide the deep learning techniques and machine learning techniques. Okay, these are the different ML and DL algorithm for NIIDs use. So the machine learning techniques is the DT, that is the decision tree, KNN, K nearest neighbor, the support vector machine, and EANN use. Okay. Machine learning algorithms is a part of AI that study the set of rule or process where the machine can impose the mathematical model for learning using the data set to find the consumable data. Some of the widely used techniques under the heading of AML now, like DT, KNN, SVM, and ANN. In deep learning, so most of the use the RNN, DNN, and CNN and DBN. So I thoroughly study these are the papers which are the existing system already available with respect to their algorithm and their methods, either DL or ML. So first methodology is the CNN, convolution neural network. Principal component analysis model and autoencoder for the feature extraction is used, and transferring the feature set into the two-dimensional matrix for the classification under the DL techniques. Next is the CNN with the GC forest in 2021. So multi-array IDA CNN for the initial detection and GC forest for the fine-grained classification, physics data transformation. Also next is the RNN. In that supervised network traffic methodology is for the classification with the tuning of hidden nodes and learning rate of for the optimal performance. RN and GRE is the next paper in 2020 combined GRE as a memory and multi-layer perception for soft matrix for the improved attack detection in network data. Next is the LSTM is used, the comparative analysis for the LSTM and CNN model for GPU based tested for the network integration detection. These are the underserved DL, and next is the ML under the ML methodology. So FLN, the fast learning networks with the PSO. So combine FLN with the particular swarm optimization, that is PSO, to enhance the introduction detection performance on the KDD Cup 99 data sets. Next is the extreme learning machine, that is the single hidden layer feed forward network, the simplify training by the randomize the input weight bias. Next is the ML techniques. Under that techniques, the fast learning networks methodology. The methodology in this algorithm is the parallel connection of the multi-layer single layer feed forward network for improving the performance and stability. Next, CGAN means conditional GAN, the collaborative IDs integrating CGAN with the block chain empower federated learning to secure the efficient detection in DL also. Next, algorithm is the deep learning in that the high performance IDs to networks EUA optimizing the real time detection in EUA environment. Decision tree in that the methodology is to utilize the tree-based classification with the proving and enhance the detection accuracy while the minimizing the overfitting. Auto coder based IDS. The autocoder IDS is used to deep in this the method uh, is the deep autoencoder for the dimensionality to reduce reduction and introduction detection in the drone networks. Next is the EANN, that is artificial neural networks. In that algorithm, use the method supervised classification using the back propagation with the hidden nodes for the pattern recognition in network traffic. Then IDS, that is human-human system inspired by the IDS. In that algorithm method is used the self-adaptive IDS inspired by the human-human system to detect the mitigate any communication threat. Next, swarm intelligence techniques. In that the IDS UA group using the swarm intelligence in detection accuracy for dynamic environment. These are the some study and their methods. So when you study the DLML and hybrid machine learning is nothing but the combination of DML ML. In that methodology, we use this DL and EML, and this is the combination of both. So the percentages uses for the methodology, the 45% up till now for the DL, and for EML is 30%, and next is 25% for the both. So in the DL, it includes the techniques like the CNN, RNN, LSTM, GRE, DBN, which are widely used to handle the large and complex data structure, particularly for the feature extraction and classification in NIMDs.
Excuse me, sir. I'm
Also,
really sorry to disturb you, but I'd like to remind you of the time limit.
okay.
Okay.
Next is 30% in that the SVM, DT, and KNN, which used to their simplicity and efficiency. Next is the combine the MLDL techniques to leverage the both strength, integrating staining with decision tree and ensemble approach to detection. So these are the methodology distribution: 25% for the hybrid DNA ML and the machine learning 30% and deep learning. So these are the number of times use the ML and DL detail analysis, the graphical representation with RF, Navy bias, KNS, all the algorithms and their detailed number of times using DL and ML algorithm detail analysis with the help of graphical representation. Next, evaluation matrix, how to evaluate all these things. With the help of confusion matrix, compromise the following essentially. True positive rating is nothing but the instant correctly identified by as an attack by the classifier. False negative in that the instant incorrectly classified when they are actually attacked. False positive in that instant incorrectly classified attack when they are normal. True negative in that the instant correctly identified as a normal. We also calculate the precision and recall for the recall for calculating detection rate that correctly classified attack instead all actual ones, and precision in that the correctly predicted attack to all the instant predictively attack, and false alarm rate, that is FPA rate. So this ratio is incorrectly predicted attack to all the actual and normal instance. This is a formula FP divided by FP plus TM. So true negative rate also calculated with the ratio correctly classified normal instance to all normal instances, and accuracy, that is detection accuracy, calculated with the help of this formula, that is true positive, true negative, divided by true positive plus true negative, false positive plus false negative. If we measure that whatever the harmonic means, we have to calculate the harmonic means of precision recall. For the balance measure, consider both on positive and negative rate. So 2 into precision into recall divided by precision plus recall. So we use the some database, okay, benchmark database up till now we use. These are the graphical representation for the benchmark database. These are the percentage, okay. So normally the whatever the database used by the researcher to access the efficiency and outline methodology. So this graphical representation used for the evaluating efficiency for the given methodology approach are regarded as a component. So in this figure, so these are the analysis of available data sets. It indicates the 60% of the time in SDL KDD and the KDD Cup 99 data set were used for the testing and validation. Both the the whatever the researcher finding in the literature, these are the percentage. Other is 4%, KDD Cup 24, NSDL K 30%. This UNSWNB 80%, Q2 6%, CSI IDS 2017 18 the 12%. So as a conclusion, so I conclude this survey. So AI-based network detection system in IDs, emphasizing the recent advantages in machine learning and deep learning. So DLT, particularly autoencoder and the DNN, deep neural networks, is highlighted for their superior feature extraction and detection accuracy with the low false alarm rate. The also their complexity and high hardware requirement, the limit real-time applicability. The system critique the reliance of outdated data set like KDD Top 99, advocating for the real world data set like CSE CSI 2018-17. Key research gap is that we include the addressing low frequency attack, producing the DL model complexity, and also for the practical use. The future work should focus on highlighted efficient DL based framework to real into detection systems. So these are the some my references we already refer for this. Thank you. Hello.
Thank you, sir. Ma'am, would you like to ask any question?
Yeah, ma'am. Sir, you just tell me, how does your approach is different from traditional machine learning or deep learning?
Actually, this system is applied on the real-time system. Suppose if you take the any organization, so in that organization you use the internet or networks. So we have just categorized the fake network traffic and true network traffics. Okay, we categorize with the help of deep and machine learning techniques.
And how did you select your data set?
Actually, CICD to 2017-18 data set is available. I also generate the real-time data set with my organization and also my uh, system.
Okay, ma'am. Thank you, sir.
Thank you, madam. Thank you, organizers.
Thank you, sir. Thank you, ma'am. We'll be proceeding with our previous paper presenter, Ma'am Sara, with the paper titled AI-Powered System for Water Leakage Monitoring, a Sustainable Solution for Urban Infrastructure. Ma'am, if you're ready, then you may start your presentation. Ma'am Sara? It
Yes,
seems...
ma'am. Shall I present?
Yes, ma'am, you can present.
Is my presentation visible?
Yes, ma'am, it is visible.
Yeah. Good morning to all of you. Myself, Sara. I'll be presenting a paper on AI-powered system for water leakage monitoring, a sustainable solution for urban infrastructure. My paper ID is 194. Like water leakage in urban water distribution system is a major problem, prompting asset misfortunate, expanded functional expenses, and ecological corruption. Customary recognition techniques depends on manual reviews and basic sensors. Okay, and usually it is not possible for us to find out the spills in a convenient and practical way. So in this paper, we are presenting a computer-based AI-powered water leakage monitoring system that helps urban network system to upgrade the effectiveness and manageability of water management in metropolitan cities. By coordinating high-level AI calculations with continuous information investigation, this framework which we have proposed offers a versatile and proactive answer for water leakage. The framework which we have used is, it uses advanced machine learning algorithms like anomaly detection, deep learning models, and predictive analytics to handle information from IoT-empowered sensors deployed all through the water network. By monitoring water pressure, stream rates, and natural circumstances, the simulated intelligence model can recognize even little breaks continuously and anticipate potential disappointment focuses before they happen. So we have designed the framework in such a way that it is possible for us to anticipate potential failures or even little failures in the water distribution system for water leakage monitoring. Now, I went through the different papers based on these particular topics. Like, there were papers on challenges in water leakage detection and AI and machine learning in water management, integration of IoT with AI for leak detection, predictive maintenance and sustainability, case studies and implementations. So my literature survey was focused on all these 5 points, and we could find quite a lot of materials on these particular things. But all these papers, when they were presenting, they were not able to provide a accurate solution for water leakage monitoring. So keeping in mind all these things and referring to all the different reference papers on these particular topics, we have come across, or we have developed the methodology for water leakage monitoring system. Now, your system architecture consists of IoT sensors which were deployed in different networks, would collect the data, and it was sent to a data communication network. And through the data communication network, the data was being transmitted into data processing unit. And with the help of our AI analytics engine, we could analyze the data what was given. So based on the data that is present from data processing unit, the AI analytics engine used this particular data to train its model. Okay, and how the data was collected. The data was collected through IoT sensors, which were deployed across the different areas. And this was sent to our architecture model, which we have used. And we have used machine learning models. So raw sensor data is handled to separate applicable highlights like tension varieties and stream deviations. Okay, and these elements were the fundamentals for training our machine learning model. Okay, then model selection was based on anomaly detection models, classification models, and deep learning models. Okay, so under anomaly detection models, we use isolation forest and 1+ SVM. And under classification model, random forest and gradient boosting machines were used. And RNN and LSTMs were the deep learning models which we use. Okay, then what we did is we trained the models and validated it. So models were trained on the historical data with known leak and non-leak conditions. Okay, so we tried both these conditions, leak as well as non-leak conditions, and the models were trained accordingly. Okay, and we ensured robustness of the system by using cross-validation. The system implementation, we developed a prototype model. Okay, so we checked it out, wherein the prototype model had sensors, information, data processing units, and artificial intelligence analytics model. Okay, then we did field testing to check whether genuinely it works or not. So wherein we could identify exactness and reaction times were checked on it on the model which you had. And then the models were evaluated based on performance metrics and system optimization. So for performance metrics like detection accuracy, false positiveness or negatives, and cost savings were evaluated. And for system optimization, okay, what we did is like adjustments were made on evaluation results so that we could improve the sensor placement, data processing, and machine learning models. Here, the results of our water leakage monitoring system. Okay, like, for leak identification, isolation forest gave us a 94% accuracy, and random forest gave us a 91% accuracy, and LSTM neural networks gave 90% accuracy, and 1+ SVM, the accuracy was 89%. And our false positive rate was 3%, and false negative rate was 5%. Okay, and this predictive maintenance algorithm successfully forecasted potential leak points with up to 30 days lead time with a success rate of 75%. We have taken 30 days lead time, and for 30 days lead time, the success rate was 75%. Okay, so AI-powered system led to a 20% reduction in operational costs and 50% reduction in water wastage. So the operational cost, it was just a case study on how we can, how much operational cost reduction has come. And based on that particular case study, we have concluded that there was a 20% reduction in operational costs, and somewhere around 15% reduction in water wastage. Now, we have collected the user feedback also, and the key aspects of the user feedback was ease of integration was 85%, and real-time alerts gave us a 90% satisfaction, okay, and predictive maintenance was 80% satisfaction rate. Okay, so let us conclude this. So the execution of computer-based intelligence fuel water spillage observing framework has shown significant progressions over customary water leakage location strategies. So with the discovery exactness of 92% with our test data, the framework essentially outflanks regular methodologies by using this AI models. And upgrade, and like future enhancements, what we can do in this is like upgrading to the UI to incorporate instinctive dashboards. Okay, dashboards can be incorporated, and adaptable cautions will further develop the ease of use while growing field testing to different geographical areas. We have taken a few small geographical area and we have tested it, so it can be tested in a larger network, so that we can actually plan of implementing this particular AI powered system in real-time applications. So these are the references which we have followed. That's it. Thank you all.
Thank you, ma'am. Ma'am, would you like to ask any questions?
Yeah, ma'am, I just want to ask, ma'am, can you open your slide number 10? Ma'am, here you have mentioned few algorithms.
Yeah.
Are you able to explain then why you choose these algorithms?
Yeah, ma'am, why we have used these algorithms is if you see this particular algorithms, the percentage is already different. So in order to compare which one is best, we have used these different algorithms. So this is the what is that leak detection percentage which we have got using these different. The same data was used in isolation forest, one class SVM, random forest, and LSTM neural networks, so that we can select the best algorithm. That is what our aim was.
And ma'am, how does your approach address the challenges in traditional power system management?
Like like what happens is like traditional power system management, it's a problem. So that is why we have used this IoT sensors, ma'am.
Okay, ma'am. Thank you.
Thank you, ma'am. Thank you all.
Thank you,
Ma'am, can I
ma'am.
leave the meeting or do I have to stay back?
You can stay back until the end of the session.
Yeah, thank you, ma'am. Thank you.
We'll be proceeding with the next paper presenter, Ma'am Beenal, with the paper titled An Intelligent Few-Shot Learning Approach for Plant Disease Detection with Limited Data. Ma'am, if you're ready, then you may start with your presentation.
Yes, madam. Just a second. I'm sharing my screen.
Sure, ma'am.
Ma'am, my screen is visible.
Yes, ma'am, it is visible.
Okay, good morning, one and all present here. My paper ID is 241 and my presentation topic is an intelligent approach, a few-shot learning approach for plant disease detection with limited data. So these are the outline of my presentation, the abstract summary of FSL in plant disease, perspective, challenges in FSL, the methods, data set, result, discussion, limitation, future work, conclusion and references. So the abstract is that as we know that plant disease must be identified as soon as possible, because numerous technologies are working with the plant disease detection, and deep learning models are there that have been developed for this topic. So conventional approaches are also there for identifying the classes of disease of planting. Classification frequently depend on large scale label data set. So what is the issue with that large imaging data set? So as I'm talking about deep learning, machine learning methods, CNN, GNN are there, but they all are working with a large amount of data. So whenever we have a numerous amount of data, then and then it will give the good accuracy and classification of the plant disease, right? So basically, what happens, so if we have a no large amount of data, we apply the augmentations and we generate the new classes and for the identifying the classification accuracy. But my approach is a few shot learning approach. So in that, on plants disease detection, it will give the promising result using the base network of FSL, and that will work with the if we have a few amount of data, then also it will give the good classification accuracy. So that few shot work with combination with triplet loss function and CNN. So if we have a limited data also, then also it gives the good accuracy. Let's assume that there is an approach of the few shot, 0 shot, 1 shot, 2 shot, 3 shot, 5 shot. So basically it is n way k shot, and n which will taken as a number of 5 in my research, and that shot will taken 1 to 50. The value of shots will increase as accuracy is increased. So on the 5-way 50 shots, so 5-way, so classification categories for the particular plant, and 50 shot we maximum accuracy achieve using which is up to the 95.27%, limited samples given the better performance. So the summary of my few-shot learning in a plant disease. So very limited work is done using the few-shot learning approach in the plant disease. Yes, there is the work in the few-shot learning approach, but in the plant disease, very limited work, because most of the cases use the CNN, GAN, SVM classifier. GAN is there for identifying the plant disease detection. So first, my paper that I have referred, that is FSL1 few-shot learning. In the base network, they use the CNN. In the application plant disease detections and the data set, they use the plant village data set. Next paper that I have referred, again the types of method, the FSL that we combine with CNN, KNN, SVM classifier. In that application, which will use the plant disease recognition in frequency domain. Again, the data set with plant village. Next paper, which is FSL cascading multiplication, is used over here with the scale, null attention. Simon's network and triplet loss function is worked over here, and plant disease recognition done in application, plant village dataset, which is used over here. Next paper, few spot learning, main method, SVM and CNN with base network, leaf spot disease classification done in this paper, image taken from the field. So they are taken image from that particular field. Then one-shot learning, that is also the part of few-shot learning. As I have previously said, that there is some criteria that few-shot learning 1, 0, 1, and 2, 3, and 5 shot. So one-shot is one kind of technique. In that base network, Simon's network, which is used, again the application, plant disease recognition, and the data set which is taken from the Kegel and plant village data sets. So multi-domain FSL in the next paper, combine base network with CNN, plant disease detection, plant village, and plant pest, which is used over here. Next paper, meta learning for the FSL. In that, the CNN and BizNet 18 as a base network, which will use the plant disease detection. Metadata set, mini plant disease data set, which is used for the finding accuracy over here. Then next paper, IMAL, in that FSL, main method, in that fine tuning with and triplet loss function with the Simon's network. Plant disease classification done, and plant village as a data set. Few shot learning next, merging with the CNN, Simon's network, and transfer learning. Plant disease detection is the application, and plant village is done. So these are the perspective challenges in future learning. So whenever we have an inaccurate data distribution assessment, then we go for the data augmentation. When we have a feature use sensitivity, then we go for the transfer learning. Then generalized of the future, then go for the meta learning. And then defect the single model information, then multi-model learnings are there. So main perspective challenges of FSL is that very limited task done and work done into the plant disease, because whenever it's we have to set with n-way k short, we increase the short, then it will give the better accuracy. So the method which I have worked with paper with convolutional neural network for presenting the base network pooling layer in that FC layer F in CNN. Then few shot learning comes into the picture with limited data sets, and then Simon's network, and then triplet loss function. So data set that I have used for this analysis, that plant village data sets, in that not n number of plants are there, but I have categorized that how much class are available that for that particular plant. So from the plant village data set, it is categorized in the 4 categories, 14 different plants are there, which is apple, tomato, blueberry, orange, raspberry, soya bean, squash, peach, pepper, strawberry, corn, grapes, cherry, and potato. And total number of class which is mentioned over here in this table, that apple have a 4 classes, 4 different category. Maximum tomato have a different classes of the disease. So in here, you can see that in apple there is a 4 different class, and the class name is healthy, apple scrap, black rot, and apple rust. In the tomato, 10 classes are there: leaf mold, Petoria, leaf spot, bacterial spot, early blight, healthy blight, spider mite, and target. These are the types of virus, and nothing with it is considered as a disease. Blueberry have only 1 class, healthy. Orange have a 1 class, raspberry have a 1 class, soybean also have a 1 class. Here peach, pepper, and strawberry have a 2 class, which is healthy and bacterial spot. Corns have a 4 classes, which is leaf blight, gray leaf spot, common rust, and healthy. Grapes have also 4 classes: healthy leaf blight, black rot, and black masters. Healthy powdery mildew, lead, and early blight, which is for the potato. So what I have actually done over here, in the base network, I have applied the CNN. CNN merging with, in the case of the CNN, I'm training the data values, or for that train classes, which is I given to the FSL. In the FSL, that is n-way k short, n which is represented how many train values or train images you are given to the model. And the K short, which is, let's say that I'm saying that I want to find the potato classes. So if I'm saying that n way K short, so one shot I have given, then one training sample I'm given to the particular class. So whenever I'm increasing the training sample, so definitely my accuracy is increased over here. First, I have done some analysis on training and validation loss on the same data sets. First, I have used the CNN. In that case, you can see the training and validation loss I have mentioned in the next table. Training and validation accuracy with CNN. Now I merge in the second task, which is training and validation accuracy with Simon's network and the few shot learning. Same training and validation loss for the Simon's network and few shot learning. So these are the results. Group of study using the various data sets and training methodology. So this data set is nothing but it is classifying into three classes, three categories. So PV1, in that 1 to 20 classes are defined, 1 to 20. So some are divided as a training and testing strategy. In PV2, 2 and 20, some are divided training and testing strategy. PV3, from 3 to 22, it is divided into training and testing strategy. So 22, total 22 classes over here. So one shot. In the first case, I have given the one sample as the training sample, right? As the sample which already refined. Then 5 shot. So to n will represent same, which is 5, and K shots will increase. So K, which is reference number, we can say that 1 shot, 5 shot, 10 shot, 20, 30, 40, up to 50 have given the samples, right? So in this case, in the first division of the training testing strategy, it will give to 57.90 accuracy. Then in PV2, it is given to 81 to 0.5. In PV3, it will given to 71.58. Whenever I increase this shot with 1 to 5, it will give the 72.90. Then in 2, it is 91.85, and in 3, 74.50. Whenever I increase shots with 10 shot, it will give 79. In the first PV1 sets, second in 93, it will give the 93.05. 88 in the third sets, 20 shots in 81.55. Then in the second, it will give 94.2, 91.0. 30 shot will give the 82, up to 82 accuracy. Then 2 will give 94.55. Then 3 will give the accuracy 91.02. 40 shot will give to 82.90% accuracy. Then 40 shot will give 95% accuracy. In the third criteria, it will give 94.0 accuracy. In the 50 shot, 83.05 accuracy, 50, which is maximum, which is 95.7 in the second scenario, and the 88. So what exactly it shows that whenever I increase the number of shots value, my n way K shot, the n is fixed, which is up to, I have refined as the 5 samples I given. Whenever I given the reference number is more, my accuracy is always increase. Whenever I decrease the reference number, whenever I decrease the shots value, my accuracy is decreased in this scenario. In the first seconds, the training strategies I've used this. Yes.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Okay.
Yeah.
Sorry, ma'am. I'll go for the next slide, which is limitation and future work. So main limitation of that, need to work with the meta learning with FSL in the agriculture domain. In a few short, apply the images taken from field also. Currently have taken from plant village, but we taken the images from the field and we can apply the FSL on that. Fusion can also apply on the multi-basis plants. Shot can apply on the cross-domain subclass classification. Accuracy can be improved by increasing the shot value in the case of NVK shot. The conclusion is that experiment results shows this paper present improved algorithm in classification plant-related dataset using the FSL. Total 38 classes are there for that 14 spices. The data are divided in the different settings. All divide settings are given ID number like E1, E2, and E3. Firstly, all settings go through the base model, which is CNN, mainly working with the learn-to-learn task. Using the CNN will give promising accuracy against require large amount of sample. So CNN will be used for the learning task using the FSL. First of all, sample divide into small data like NVK shot. Here, all the settings are divided into 3 splits, and then FSL is applied to the table 4. So represent the different accuracies on the different sorts. Once we increase the number of short samples are increased the classification accuracy as previously told, and these are the reference that I have used in this paper. Thank you. Thank you. Done from my side.
Thank you, ma'am. Ma'am Jyoti, would you like to ask any question?
I just want to ask one question from you, ma'am. How did you select your data set and does it represent real world scenario?
Yes, ma'am. I have referred so many paper. In that case, almost the cases whenever we work with the plant disease detection, plant village data sets are used. But they use CNN and GN, so they use apply the augmentation and merging with the different spices. But in the future learning, I have only the limited plants used from that plant village data set. So I have just taken the data set from Kaggle.
Yeah, ma'am. I have one more question. How did you split your data into training, validation, and test sets?
Yes, ma'am. In the first scenario, I have divided that 20 to 80%. So I have divided 20% as the training and 80% testing strategy. Then I have divided 70 to 30 and then 60 to 40.
Okay. Okay, ma'am. Thank you.
Thank you, ma'am. Thank you so much.
Thank you, ma'am. We'll be proceeding with the next paper presenter for the session. I'd like to invite paper presenter Naveen with the paper titled Improving Package Structure Using Cost-Effective Software Modularization While Considering Expert Knowledge. So if you're ready, then you may start with your presentation.
Yes, ma'am. Is it visible screen, ma'am? Hello?
Yes, sir, it is visible.
My topic name is Improving Package Structure Using Cost-Effective Software Remodelization by Considering Expert Knowledge. Uh, this is a table of contents. First one is introduction, second one is literature review, number third proposed approach, experimental and result, conclusion and future work, and last one is references. Introduction in the field of software engineering, modular design plays a major role in project modularity has several design principles. However, separation of information hiding are among the most influential factors that determine the quality underlying modular of a software system. Software maintenance is prolonged or generally hindered due to the complex structure of the software difficulties. Next paragraph is software remodelization is among the preferred ways adopted by the maintainers to obtain modularity. Most of the existing research focuses on the problem of automatic decomposition rather than enhancing existing software decomposition techniques. Becomes difficult to understand obtained remodelized solution and validate it easily. Sometimes the obtained remodelized solution has a big bang design as a uh, original design structure, and the designers generally reject the solution improvement in terms of modularity. Next one is a literature review. Ma'am, have you seen properly?
Yes, sir.
Next one is a literature review. Uh, in this session, we summarize the literature work in the domain of software remodelization and give details of identified research gaps. The author carried out a systematic survey in the direction of improving software modularity. The paper considering 54 primary and summarized their work along with the uh, maintaining possible research gap. The authors proposed an information-driven, many objective search-based artificial uh, colony optimal techniques for pre-forming software remodelization. The author used to three information, structural, lexical, change history information. Further, they construct six test case applied and optimization algorithm. The main research gap of this study is that authors consider weighted combination by considering six test cases. They treated uh, each information quality. The author proposed a modified discrete. एक मिनट sir, online. एक मिनट मैम, little bit a technical problem I have faced. ये पूरा नहीं आ रहा है. The author in a proposed modified discrete sand CAD SWAM optimization approach to perform software remodelization. The author created a dependency graph and applied a proposed modified optimization algorithm to perform clustering. The possible research gap in this study is that they use only structural information to create a dependency graph. The author used a semantic clustering algorithm to recursively identify further NV codes symptoms and perform software remodelization to mitigate them. The possible research gap is that they rely on the semantic information to perform the underlying remodelization process. The author in 9 considered the software clustering problem and proposed a multi-objective information sharing different evolution algorithm. The author used to concept a population sharing to lack diversity problem during different generation. The possible research gap here is that proposed algorithm feasibility needs to be tested for a software remodelization. Similarly, author tackled the software clustering problem by proposing a different evolution-based clustering problem. Next, we go to a proposed approach. This section of the paper discusses the proposed solution that tackles issues related to optimizes the modular structure error. Reference sources not found gives an overview of a proposed cost-effective software remodelization approach. It takes the software source code as input to perform a cost-effective remodelization. It generates move class suggestions that help in improving the software system current package structure by representing the expert knowledge. It consists of 3 main phases: performing source code, analysis, creating software dependency function graph. Third one is performing software remodelization. Computational relative weight values. The first category of exploiting information include the structure dependency relationship existing in the class level in a software system. Structure relations are found to be directly related to the modularity principles of software system. Multiple triple kinds of a structure relations generally exist between classes. The paper is considers 2 such types of a structure relations as important: share functions called SFC that denotes the call-based dependency, and share class attribute SCA that denote the class attribute-based dependency. This paper uses these 2 kinds of a structural relation and their relative weights to compute structural relation based coupling strength. uh, it is basically on a reverse engineering process, and coupling refers to degree of interdependency between software modulation. A good software economically we found low coupling should be low and cohesion should be high. This is a mathematical formation classes used upon total classes CS relative weights multiply. Here, class use denotes the total number of classes from the package PJ that are found to be the functionality defined by the class CI, measured in terms of SFC and SCA. As any given class C may be connected with more than a package simultaneously, therefore, the actually CSSTR is computed using. And next one is uh, source code analysis. This is the first phase to proposed approach that takes source code files, a software uh, system as an input, and extracts key information that is used to in a later stage to perform optimal software remodelization. This paper considered 2 sources of information important from a software remodelization point. We use CI, total attributes A1, A2, AN, and CI packages CI that denotes, and method is M1, M2, M2 total method defined. Experimental setup and result. This section of paper gives a detailed description of considering experimental setup used for analysis and analyzes the detail of the optimal experimental result. table below gives the necessary details about the data sets considered in this paper for carrying out the experimental evolution. Different information specified in this table includes the software name, the corresponding version considered, the total number of classes and packages, the total number of connections,
Excuse
dependency
me, sir.
between classes, and so. Ji,
I'm
ma'am.
really sorry to disturb you, but I'd like to remind you of the time limit.
Okay, ma'am. I go to a conclusion and a future work. Here we
Sure, sir.
propose a new software remodelization technique which improves the package structure of software using cost-effective consideration and expert knowledge. The proposed technique consists of three main steps. First, multiple dependency information structure and semantic information is extracted. In the second phase, these multiple dependency information sources are fused, and this consolidated information is finally presented in form of weighted direct graph in the class level. This graph acts as a main input for the proposed remodelization technique. In the third phase, we applied our newly proposed remodelization approach based on an n-state force model to perform remodelization and obtain variance move class remodelizations. Finally, these remodelizations are evaluated to obtain a new improved package structure for a software system. The feasibility of proposed technique is justified by carrying out experiment evaluation using a standard classic. These are the references. Thanks, ma'am.
Thank you, sir. Ma'am, would you like to ask any question?
Yes. Sir, are you able to explain your research gap in this paper and what is the methodology?
In a research gap, I have read more than 25 paper, and methodology is based depends upon a reverse engineering process that we have to develop economically and in a time limit and technically strong software development process.
So, what is the main objective of this paper, sir?
Main objective is, ma'am, we how we can use structural analysis, semantic analysis, source code files to develop a remodelization solution that is better than a uh, traditional software system.
Okay, sir. Thank you and best of luck.
Okay, ma'am. Thank you. May I leave, ma'am?
Sir, you could stay till the end of the session.
Okay, okay.
Okay.
Thank you.
Thank you, sir. Thank you, ma'am. We'll be proceeding with our next paper presenter for the session. I'd like to invite paper presenter Edidiong with the paper titled Information Technology as a Catalyst for Change in Education from Traditional Classrooms to Digital Learning Spaces. So if you're ready, then you may start with your presentation. Sir Edidiong,
Yes, good morning, ma'am. Is my screen visible, please?
a second, sir. Yes, sir, it is visible. Please go ahead.
Okay, thank you. Yeah, please give me some time to find it. Okay, so good morning, everyone present. My name is Edidiong Okpabio from Datamega Institute of Higher Education and Research, Wada, India, and I'll be presenting on the topic Information Technology as a Catalyst for Change in Education. So these are the contents we have: introduction, literature review, the IT applications, the benefits of IT in education, challenges in implementing IT in education, future trends, conclusion, as well as my references. And then let's start with the introduction. So the rapid development of information technology has transformed so many sectors as we can see today, but education is the top of the list. And then tools like have augmented traditional models of education by providing greater flexibility, inclusivity, and accessibility. Among most of them are the learning management systems, the massive open online courses, MOOCs, and other learning virtual environments, which have broadened the scope of education across geographical and temporal boundaries. And then we can see that the delivery of content is revolutionized using interactive teaching tools like virtual learning, virtual reality, augmented reality, and gamified learning experience, and which, of course, all these tools have encouraged active participation from students. And then I have looked at some papers that have actually talked about this and said, yes, we should use that yes, IT has done so well in education. Like Farana Yusuf said that they had introduced multiple avenues for information sharing, as well as knowledge sharing for teachers as well as learners, respectively. And this helped during the COVID-19 pandemic, where we saw where there was no schools were closed and all. And then Jaroslav Kuta also pointed the need for young, educated people to speak and know the latest technologies available in the market today. And then also, Vaishali Lagwani also talked about the shift from conventional learning to electronic learning environments. And then Prasad and Gupta also explained that education ICTs are those that were designed mainly to fulfill the purposes of teaching and learning, hence taking their prime place within their specificity. So what are these IT applications in education today? We can see like the online learning platform, where we can see that the facility in the platform offers students access to content at their leisure time and choice of location, thereby creating a more all-inclusive learning environment. For example, we see elements like Moodle, Blackboard, Google Scholar, and so many others that have made learning an inescapable feature for both instructors and learners as well. Then we also have interactive tools and learning management system, where we can see smart boards, virtual labs, and educational applications. They have all dramatically altered the face of content delivery and understanding through an interactive real-time interaction between the instructor and the learner. Where we can see, take for example, Coursera, where they have done so much and they have incorporated all these features together. And finally, we have data analytics in education, where it allows teachers to track student performance in real time, and then showing how they are interacting with the materials, how often they pose a discussion, and the places they might be falling behind. All of this we can see an example of that is Coursera platform. And then what are the benefits of this? We see personalized learning. A learner can learn at his own pace, at his own time, and at his own convenience as well. And then it also increased accessibility to education. You see, and then this online courses, mocks, and virtual classrooms help to bring the same quality education for students from distant, inaccessible, or less privileged areas to reach a central place that was available only in a well-developed urban centers in the past. So even if you are at the village or at a remote location or a rural area, you also can have access to learning online with the help of an internet connection. And then what are the challenges available? The IT in education. We have digital divide. What does this mean? This means that the poor IT infrastructure in some regions may limit the accessibility of such devices and the stable internet needed for full participation in digital learning environment. So we can see like some of like streaming, the internet connectivity can, if it's not regular, then you can have problem streaming the video lecture or downloading resources or even uploading your assignments online. And also there's a need for quality hardware such as a laptop or a tablet. Like there are some phones that can't really use it, like Nokia, like we have the button phones and what's not. So we can't use that to go online for learning. And then also teacher training and resistance to change. Yeah, actually some places it's difficult, especially in rural areas, talking to the old teachers, like we actually see in rural area they have old teachers. So like teaching them somebody of 70, 80 years how to use this particular means and medium gives a problem. And then we can see the future trends. Then one of them is artificial intelligence in machine learning, where AI is the talk of the town now. It's everywhere. So we can apply them in developing AI powered tutoring systems where they can provide personalized learning for the needs of an individual student. Like an AI tutor may examine the responses of students to questions and observe different patterns in their mistakes, and then provide them feedback in their area of weakness. And also automated grading, instead of taking 3 weeks, 4 weeks for a result to be out for a particular class
Excuse me.
after exams, using
Really
AI.
sorry to disturb you, but I'd like to remind you of the time limit.
Okay, no problem. I'm almost done. Thank you. So it can help as well. And then using a virtual and augmented reality, where history students could experience life like ancient Rome or the Great Wall of China. If medical students can also use that to practice surgery in a risk-free environment. So in conclusion, IT integration in education has changed all aspects of learning, delivery, access, and assessment. So these online tools have made education more personalized, accessible, and engaging. And also in future, we hope to see the integration of AI, VR, and AR together for educational experiences. So these are some of the references I have, and thank you so much.
Thank you, sir. Ma'am, would you like to ask any question?
Yeah. Sir, I just want to know that what is the main objective of your paper?
Okay, the main objective of this paper is to review the the change information technology has done from the traditional classrooms where we were up to the digital learning
Which
space.
which slide is related to your objective?
Like these applications, actually.
Okay, these three are your objective of your paper, huh?
Yes, ma'am.
Okay. And what methodology which you are going to follow?
We have this is actually not an original research, ma'am. This is a review of what has been in place. Like I'm bringing it back in place, like to tell people this is how it was before, and now this is what is happening now.
ठीक है. Okay. Best of luck for this. Thank you.
Yes, thank you, ma'am.
Thank you, ma'am. Thank you, sir. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter. One second. Yeah. I'd like to invite paper presenter. Aditya with the paper titled Leveraging Machine Learning for Accurate Real Estate Price Forecasting in Mumbai Metropolitan Region. So if you're ready, then you may start with the presentation.
Yes, ma'am. I'll share my screen.
Yeah, sure.
Okay, ma'am. Is the screen visible?
Yes, sir. The screen is visible. Please go ahead.
Yeah. So good morning, everyone. I am Aditya Pankar, a student from Thodamal Chani Engineering College. I am accompanied by my co-author Josefa Duhadwala here today, and I'll be presenting our research on leveraging machine learning for accurate real estate price forecasting in Mumbai metropolitan region. So Mumbai's real estate market has been experiencing like a rapid growth due to increasing urbanization. This makes accurate house price prediction very crucial for both buyers and sellers to make informed decisions. However, predicting house prices in Mumbai is particularly a very challenging task due to multiple factors being involved, from the location of the real estate project till the carpet area, also including amenities and the furnishing status. So we looked into some former study in this field of real estate price prediction. So from the previous research in this field, it has shown some promising results with using machine learning approaches. 2020 study comparing the support vector regression model and the XGBoost achieved like the R squared values of 0.799 and 0.789 respectively. Another study from the same year using random forest and XGBoost showed somewhat a lower performance with R squared values. Also, a more recent work in 2023 explored a more recent regression technique called a ridge regression, also decision trees with more lower accuracy scores. So these studies laid some good groundwork for our research, showing the potential of ensemble methods while also highlighting areas for improvement in prediction accuracies. So for our processing, uh, in this study, we utilized a very comprehensive open source data set from Kaggle, which contains around 6,256 entries. It also has like 17 different features and columns, and this data set is calculated around the Mumbai metropolitan region. So there are a lot of features, including the price, the location, the coordinates, carpet area, even the number of bedrooms and bathrooms, even parking availability, and also various amenities. So our methodology involved firstly is we conducted thorough data pre-processing, which included handling missing values and removing features with more than 20% missing data.
You haven't changed the slides of your PPT?
Wait.
Yeah.
Yeah, I wanted to show this slide itself. Yeah. Were the previous slides visible or?
No, actually, they weren't like you didn't scroll through the slides. It was stuck on the main.
Oh, okay. Sorry. Like I was doing a slideshow and like I don't know what happened. Okay, so I'll quickly recap.
Okay.
So yeah, basically, the real estate market in Mumbai has been like uh, having a lot of growth due to more urbanization. So our main objective is to provide accurate house price prediction for both buyers and sellers to make informed decisions. We the previous research in this field also showed a lot of good progress. It we used the previous studies used algorithms like SVR, XGBoost, random forest, and decision trees, but most of them had a very low accuracy rates. So for our research, we there was a good amount of groundwork, and like there were also a lot of areas which needed improvement in the prediction accuracy. So in our pre-processing again, firstly we conducted a thorough data pre-processing which included handling missing values and removing features with more than 20% missing data. We then applied a standard variance scaling using correlation metrics for feature relationships and also Kramer's V rule for categorical variables. We used one hot encoding as well for categorical variables. Lastly, the price variable, which is the target variable, was also scaled down to the 100,000 to avoid any skewness in the dataset. So for our analysis, we carefully selected 7 different machine learning algorithms, starting from linear regression, which we used as a baseline model. We included ridge regression to address multi-collinearity issues. A support vector regression was chosen for its ability to handle non-linear relationships using kernel functions. We also implemented a decision tree regression as a foundation for our ensemble methods, which included random forest, cat boost, and XGBoost, as they are known for high performance with structured data and categorical features, which are included in our dataset. Okay, so for the results, our comparative analysis of all these models revealed like the traditional linear regression model served as a benchmark and achieved around a 63.4% accuracy. Regression showed a marginal improvement with 64.5 accuracy. Uh, the more advanced algorithms demonstrated better performance. Hello. Okay, yeah. The more advanced algorithms demonstrated like better performance, which includes SVR, decision tree, random forest XGBoost, and CAD boost, with CAD boost being our leading model with accuracy of 81.1%. So these results clearly indicate that ensemble methods were more capable of capturing complex relationships in our dataset, as they had about 17 different features involved in it, compared to more traditional approaches, which included linear regression. So, in conclusion to this research, we demonstrated ensemble methods and particularly cat boost regressor, which provided most reliable predictions for house prices in Mumbai. The superior performance of these models can be attributed to their ability to handle both numerical and categorical features while capturing on complex non-linear relationships in the data. This research contributes to making Mumbai real estate market more transparent and efficient, helping stakeholders, buyers, and sellers to make better decisions. So, thank you for your attention, and I'm happy to take any questions. These are also the references of our data research.
Thank you, sir. Ma'am, would you like to ask any questions?
I just want to ask, how did you select your data set?
So, ma'am, we went through a couple of data sets through different sites, for example, Kaggle and Hugging Face. But the thing was, we found this data set the most interesting because it had more number of features. It had up to 17 features, and those features included different parts such as latitude, then there's amenities, furnished, etc. So we decided that we'll move on with this data set.
Okay, and tell me, how practical is your model for deployment in real world scenario?
Ma'am, it is on the moderate level of practicality. If we need a more higher accuracy model, we'll need to delve into deep learning models. For example, we'll need to use neural networks, which can handle more complex data compared to, CAD boost or ensemble methods.
Okay. And what is the most important innovative highlight of your research?
When we compared our results with papers that we have previously checked for for research purposes, so our model had a better R squared value. That means our model had better accuracy with a low RMES score. That means we had a very less error rate compared to previous studies that were done on this same thing.
Okay, one more question. How does your approach is different from traditional machine learning or deep learning methods?
So, ma'am, currently what we did was we did not just start implementing and uh, sorting out results. We tried and tested different approaches. We tried different standardization method. We tried different normalization methods, and then compared the same algorithm with different methods, and then came down to a conclusion that for this particular algorithm this is the best performance that we are achieving.
Okay, okay, beta. Thank you and best of luck.
Thank you, ma'am.
Thank you.
Thank you, sir. Thank you, ma'am. We'll be proceeding with the next presenter. I'd like to invite paper presenter Bhavika with the paper titled Transforming Urban Parking, Intelligent System for a Better City Experience. Ma'am, if you're ready, then you may start with the presentation.
Yes, good morning. Am I audible?
Yes, ma'am, you're audible.
Let me share my screen. Just 1 minute. Is my screen visible?
Yes, ma'am, your screen is visible.
Okay. So good morning to everyone present here. I'm Bhavika and I will be presenting paper ID 113. Yes. So first, the outline of this presentation, I will be introducing you to the problem we are dealing with, and then walk you through the proposed system and end with the possible future enhancements. So first, sorry. Yeah. The rapid rise in vehicle ownerships has made all our lives easier, but has also given rise to many problems like traffic congestion, illegal parking, and safety risks, and also environmental issues. And unauthorized parking often leads to blocked driveways or reserved spaces being misused, which creates inconvenience for everyone. So in this paper, we are going to propose a system that tackles with this particular issue, that is illegal parking. Yes. So while reviewing multiple articles and papers, one major cause for illegal parking was identified, and that is the demand for short-term parking. So basically, when a person doesn't want to park for long and just maybe for 5 minutes or 15 minutes, they need to pick something up from a shop. They don't want to find a parking spot away from the shop and just park in front, regardless of it being allowed or not. And none of the existing systems we went through address this issue. And the major challenges in coming up with a solution were to balance the needs for both long-term and short-term users, and to monitor and make sure there is no unauthorized parking. So the proposed solution is a system that minimizes illegal parking and uses Dijkstra's algorithm for accurate spot allocation. Yes. So while reviewing, I'm sorry, yes. Existing parking approaches mostly focus on faster spot allocation or finding the closest spot available. And most of these approaches use algorithms like Dijkstra's algorithm, Bellman, Ford, and all those algorithms. But there is no solution addressing the short-term parking issue. And there is also not enough tracking of vehicles once the spot is allocated. Yeah. So this is how the system works. So it's basically in a parking lot, every spot is given a unique ID for monitoring and convenience. When a user requests to enter the parking lot through the UI, the system checks for empty spots, and if there are spots available, it applies Dijkstra's algorithm and allocates the closest spot from entry to the user. The user is notified of the ID for unique identification. And once the allocation is done, a timer starts for that specific spot and keeps track of the time the user stays. So now long-term and short-term parking is implemented in the system. Uh, like they have a fixed time limit. For example, we could take like 4 hours for long-term and maybe 1 hour or half an hour for short-term. That of course can be changed based on application. And when the spot timer is up, uh, timer is up, the user also has an option to extend their stay or leave the lot. So to explain this in detail, we implemented a simulation which I will be showing you. Yes. So we took a very basic 5-on-5 grid for the parking lot. And then the figure on the right was used to represent the parking lot. So each spot is basically a node of the graph identified by a unique ID, as you can see. And the edges of the graph is basically the distance between the spots. So the lot is also divided into 2 and 4-wheeler parking spots. And It was the method implementation was divided into 4 modules. Let me give you a more detailed explanation using this. So, yes, the flow of the system goes like this. So, when a user is entering a lot, they are asked for preferences, as you can see in figure 3 on your left side. So here, the user first tells whether it's four-wheeler, two-wheeler, and then their term of parking. So their long-term or short-term durations. And then, as I mentioned before, these long-term, short-term durations are fixed with some predefined limits that can be changed according to application. So after the user gives their preferences, the system looks for any empty spots. So in the graph, the different sizes of nodes, as you can see in figure 4 and 5, different sizes represent for two-wheeler and four-wheeler spots. So now each spot has an ID and tags that indicate whether they are free or occupied, whether they're long-term or short-term, and also every spot has a timer, has a unique timer attached to them. So when an entry request is made, for example, it is a two-wheeler that wants short-term parking. So when this request is made, the system checks if there is any unoccupied tags basically. And then if there are spots present, Dijkstra's algorithm is applied to find the spot closest to the entrance and is allocated to the user. So when this allocation is done, the assigned spot is highlighted for convenience. As you can see in figure 4, it turns green for short-term parking, and in figure 5, it turns pink for long-term parking. The timer of the specific spot after allocation basically counts down the predefined time limit that I told you about, depending on the type of parking. And yeah, after this, so let's say the user stays for some time, and when their timer expires, that is for short term when they hit their limit, and long term they hit their limit. So after this timer expires, the user is given an option to either stay or leave. So if the user wants to say, the timer is reset and it starts again to count the overstay time and calculates an additional fee based on the extra time. And the UI is also represents this extension of time, as you can see in figure 7, by turning it yellow, turning the specific spot yellow. But if the user chooses to leave the spot when the timer expires, the deallocation of the spot happens and the status of the node is the spot is updated to available. And as you can see in figure 8. So this system basically ensures the accommodation for both long-term and short-term parking users. So they wouldn't have to park in random places. Yes. So apart from this, user can also like exit when before the timer expires by entering their spot ID, and the system also handles situations where the parking lot is full or they enter the wrong ID. So basically, error handling is present, and yeah. So the system deals with the major focus is illegal parking issue, but we also reduce problems like congestion. So the table here shows the time taken to find an empty spot with and without the proposed system. System time was used to calculate the timings, where a simple linear search represented a normal search. That is, the timings are in column 2. And after applying the system, the timings to find a spot are in the last column towards the right. So as we can see, the time finding finding the spot is reduced by almost 50%. And so we can say that it tackles illegal parking and also makes the user experience more convenient. Yeah, this is the same thing. And yeah, some challenges to implementing.
I'm really sorry
Yeah,
to disturb you, but I'd like to remind you of the time limit.
yeah, sure. I'll continue. So the proposed system efficiently reduces illegal parking, enhances user experience, with efficient allocation and offers significant potential for future scalability. We are currently working on optimizing the spot allocation by trying multiple algorithms and scaling the system to include multiple entries and exits to represent the real world scenario. And yeah, these are the references we use to study the existing systems. And thank you.
Thank you, ma'am. Ma'am Jyoti, would you like to ask any question?
Yeah, I just want to know that what is the primary objective of your paper?
Yes, ma'am. So the primary objective of the paper is to reduce illegal parking. And then after going through several articles and papers, we found several reasons for illegal parking, and one of the major ones was the need for short-term parking. So this system focuses on addressing that. We are planning to extend it to optimize it more.
Ma'am, you're on mute. Ma'am Jyoti, you were on mute.
And ma'am, what about your research gap?
Research gap from existing systems or from my paper? Can I just make it clear?
From existing, ma'am.
Existing systems. So most parking systems, they focus on, the fastest way to find a spot and also finding the closest spot to the entrance. Most of the, almost all focus just on these two. They don't address the illegal parking issue, which we have dealt.
Okay, thank you.
Thank you. Thank you.
Thank you, ma'am. That was our last presenter of the session. I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTCS 2024. I'd also like to thank our session chair, once again, Professor Jyoti Shekhawat, for chairing the session. A token of appreciation to the chair on behalf of Team ICTCS 2024 and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am.
Okay, thank you so much, ma'am, for inviting me. Thanks a lot.
Thank you, ma'am. Just before we end the session, I'd like to request everyone to turn on the cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.